All right, in this video we're going to introduce parabolas. We're going to find the vertex, focus, and the equation for the directrix for parabolas in standard form. So if we look at the graph of a quadratic function in the form f of x equals ax squared plus bx plus c, we're going to obtain what's known as a parabola, and you may have seen this in prior math classes. Parabola is the set of all points in the plane that are the same distance from the focus point as they are to the directrix line. Now, what does that mean? Well, here's our graph of a parabola. So here we have a parabola opening upward. What that definition means is that if you take any point on this blue parabola curve, so let's say we have the point right here, whatever this point is, the definition is saying is if we measure the distance from this point to the focus point, it's going to be the same as the distance from this point to the directrix line, and it's going to be the same for everything else. So this distance from this point to the focus is going to be the same as that distance to the directrix line. And we have a special point on the parabola called the vertex, and again, that vertex follows the same rules as any other point on our parabola, on our blue parabola here, that the distance from the vertex to the focus is going to be the same as the distance from the vertex to the directrix line. And the focal length is the distance that is either between the vertex and focus or the vertex and directrix line, because the distance from vertex to focus, again, is going to equal the distance from vertex to the directrix line. And that distance, we have a variable for it we call p. And if we look at the absolute value of p, so again, sometimes we'll see in our equations we'll have negative numbers. We want to make sure that the distance is never negative. So we take its absolute value, and the distance here will match the distance here. That is the absolute value of p, called the focal length. So for parabolas in standard form, we have a couple cases. Our first couple cases are the parabola is either going to open up or down. So here we have an example of a parabola that opens upward. So depending on some conditions here, we have x minus h in parentheses squared equals 4p times y minus k. Now, depending on whether or not this 4 times p comes out to be positive or negative, if it's positive, it's going to open up. If it's negative, it's going to open down, as we'll see with the graph. The vertex is of our parabola is h comma k. So it's the h is here and k is here. Notice again the minus is in front of them, which we'll see what happens with finding the vertex when we look at the equation a little bit later on. Our focus point is going to be, if this is the coordinate of our vertex, remember p represents the distance from the focus to the vertex. So if we add, if it's opening upward, we're going to add that value of p to the y coordinate of the vertex to get our focus point. And likewise, we are going to subtract that value of p from the y coordinate to get our directrix line. So keep in mind also our directrix line, if a parabola is opening up or down, is going to be a horizontal line, and the equations of horizontal lines are y equals wherever it happens to intersect the y-axis. All right, alternative to opening up or down is opening left or right, and really the difference between the two equations is we switch the parentheses. So here we had x minus h being squared for opening up or down. Now we have y minus k being squared for opening left or right. We had 4p times y minus k. We switched it. Now we have x minus h over here. So it's really just switching the parentheses around from the left and right. Vertex is still h and k. So again, the h is always associated with the x. The k is always associated with the y. Even here, h is associated with x, k is associated with y. This time our focus point is going to be adding our value of p to our x coordinate of our vertex. And directrix line is going to be subtracting our value of p from our x coordinate of our vertex. And again, if p is positive, our parabola is going to open up to the right. If p is negative, it's going to open up to the left, as we'll see. Now, in prior math classes or in other contexts, you may have seen the equations written in terms of y or in terms of x. So, for instance, this first equation is what you get if you divide both sides by 4 times p. Sorry, my dog was shaking. and then add k to both sides, you'll get this first equation. For opening left or right, if we divide both sides by 4p and then add h, we'll get this second equation. So either this one or this one is fine. Same thing with opening left or right. Either the form here or form here is fine. We're going to work with these forms up here, but just keep in mind that they're equivalent to these forms down here. So if you've worked with these ones in the past and are more comfortable with them, you might want to write your equations that you'll see solving them for either y or solving them for x. So I understand sometimes you're not going to have technology available, so we'll see how to find the vertex easily for these forms. But if you don't have technology available and want to find the vertex real quickly, for y equals ax squared plus bx plus c, the x-coordinate of your vertex is negative b over 2 times a. And then to get the y-coordinate of your vertex, just plug that value that you got for your x-coordinate into your function. So if you don't have technology, it's going to be a little bit of paper and pencil math. For x equals ay squared plus by plus c, so these would be ones that are opening either left or right, your y-coordinate of your vertex, because we're switching the x and y's, is going to be negative b over 2a. And then to get your x-coordinate, just plug that value into this function, whatever it happens to be. So if you're without technology and your parabolas are in this form or that form, you're going to be okay. But for the most part, we'll be using technology for these. All right, example 1, we're going to find the vertex, focus, and the equation for the directrix line for x plus 1 squared equals negative 8 times y minus 3. So first of all, let's graph it. And notice that our parabola is opening downward. And because it's x plus 1 being squared, that means it's either going to open up or down. And this value here in front of the y, the 4p value of negative 8, if it's negative, it opens down. If it was a positive 8, it would be opening up. And our vertex in this one is going to be right here. And the coordinates of that point, which in Desmos is really easy because you could just plot this and then touch the little gray vertex point. Our vertex is negative 1, 3. Now we can get that by looking at the equation. Notice we have a plus 1 with the x and a minus 3 with the y, and your h and k are associated with x and y respectively. So we just, with the x minus h, we just look at whatever's after the x and take its opposite, because that's what the minus does in front of the h. It means take the opposite. So the opposite of positive 1 is negative 1. The opposite of negative 3 is positive 3. So a quick way to get the vertex for looking just at the equation. All right, because our vertex is at negative 1, 3 and our parabola is opening downward, our focus point is going to be below our vertex, so it's still going to be inside the cup. Our directrix line is going to be above. So to find the vertex, or to find the focus point and directrix line, we're going to take 4p and set it equal to the absolute value of negative 8, which is 8. And then divide both sides by 4, you get p is 2. Now the reason I use absolute value is because I like to graph it, so graphing paper, technology, or whatever. For the focus point, I'm going to count 2 spaces below the vertex, so that's your value of p, 2 spaces below. And then for the directrix line, I'm going to count 2 spaces above. So I'm very big on graphing the conic sections. So our focus point is going to have the same x-coordinate as the vertex, but now we're going to go 2 spaces below and going to put that point at negative 1, 1. For our directrix line, we're going to go 2 spaces above, and 3 plus 2 here is going to give us y equals 5 as our directrix line. And our vertex, once again, negative 1, 3, our focus point at negative 1, 1, and our directrix line at y equals 5. All right, for example 2, we have y minus 2 squared equal to 12 times x plus 1. Here, if we graph it, our parabola is opening to the right, which, again, if this value here in front of the parentheses that aren't being squared is positive, and for x, it's going to open to the right. So our vertex, we can use technology to get it, or we can look at the equation. So we have a positive 1 with x and a negative 2 for y. So taking the opposites of positive 1 and negative 2, we get our vertex at negative 1, positive 2. To get our focus point, we'll take 4p equal to 12, which means p is 3. So from this vertex, we'll count 3 spaces to the right to get our focus point, and 3 spaces to the left to get our directrix line, which in this case is going to be vertical. Your directrix line never going to hit your parabola. So counting 3 spaces to the right of our x-coordinate, we're just going to add 3 to -1, and we get a focus point of 2, 2. For our directrix line, we're going to subtract 3 from our x-coordinate, and that's going to mean our directrix equation is x equals -4. So in example 2, our vertex -1, 2, our focus point at 2, 2, and directrix line at x equals -4. All right, that about does it for this video. I will see you next.